Hello there. This one is about Unit 6 and a recap of that. The way we were ranking things is we were pretty good at the beginning because that was kind of a review of your first year chemistry. But then towards the end, when we got into the AP Chem stuff, you can see the 2s start to pop out more. That's indicative that we're looking at AP stuff, and that got a little tougher for you. Didn't quite come back to memory. Other results would show that review game-wise, red is a yes, yellow is a meh, I don't care, and this blue and green is maybe, maybe not, and this blue is no, I'm good. So that's about 3 people right there. So I'm going to do some sort of game sort of thing. If you don't want to play, that's okay. Your team might give you a little bit of a scowl sort of thing, but they'll get over it and it'll be fine. So don't you worry. I think it should be good for everyone, whether you're a yay or a nay or a meh. As for scores here, the top score is a 13. You can see where we're kind of sitting kind of really distributed out. Somebody asked, what kind of score should I be getting these things? You should be getting like an 80% or better. If you're getting 80% or better, that's where you should stick. That's going to be where the 4 or the 5 in the AP test is going to be. If you're sitting lower than that, then you got to do a little bit more reviewing, right? Like on this one, in the AP test, if you get a 78, you're going to be getting a 5, and so that would be a 10 or better. If otherwise, looking at 8 or better would be the 4 in the AP test. But this is a very short amount of things, so that's kind of where you should be setting. I'd say 10 or better for sure. That's where I would expect for you. So sitting 80% or better for all these tests is where you want to be. Questions I want you to go over today would be 2, 3, 10, and 11. 2 and 3 were requested. 10 and 11 were the top ones to get wrong. Somebody did ask about a video chat. I'm thinking Thursday's a good day. Thursday is the day I'm going to tell you about the AP test. I'm sure you've heard things. I'm going to give you the chemistry AP test information. I'm going to talk about grades and the game. So those are the big 3 that I want to talk about on Thursday. Okay. So let's talk about the questions. Number 2. Number 2 is talking about the heat flow. So in this problem, the amount of energy that's needed to break the bonds, the activation energy, is different depending if it's catalyzed or not. The dotted line is your catalyzed line. The solid line is the uncatalyzed line. And you can see that the activation energy for those is different. But no matter what you're looking at, the heat is always the same. The heat is always the before and the after. And that's all we care about here. So it doesn't matter what path you take. Therefore, we're looking at 50 kilojoules per mole. This is an upper, so it's an endothermic. Endothermic means you have to absorb energy. An exothermic would drop down. This is endothermic, so I'm looking at 50 kilojoules, and it's transferred from the surroundings. Endothermic has to input it, so it's coming into the surroundings. So that's why that one. Number 3. This one you'd have to reread it again if you don't remember this question, but I want to go over why A, B, and C are not good and why D specifically is good. So what A talks about, like I said, you'll have to reread it. A talks about how the lower energy ones or the slower ones are getting even slower and the faster ones are getting even faster. That doesn't work. We're talking about a cold bucket of stuff and a hot bucket of stuff mixing together. And why is the temperature like an average temperature? It's not because the slow ones are going slower and the fast ones are going faster. That doesn't work. B's answer says, once I saw the word same speed, I knew we were not looking at the right thing. Same speed, that means everything has the same speed. That's not possible. The Boltzmann distribution curve, it's an average speed. Never everything is the same. And then C, it said that it's going to all have the same kinetic energy. Everything is not ever going to have the same. So once I saw those words, I automatically just stopped reading because I know it wouldn't work. D is the best answer. D talks about how these slow guys are moving along and the fast guys hit them and make the slow guys go faster and the fast guys go a little bit slower. And that creates this like average kind of like temperature between the hot and the cold when they mix. So D is the best answer. That was 3. Now we're going to number 10. Okay, so for number 10, I have the problem for you right here. Okay, so for number 10, the first thing I would do when I'm looking at this type of problem is I'm going to draw those dot structures. I've got O2, it looks like that with a double bond, going to make 2 O's. There's no bonds over there, so I just wrote 2 O's. I know this one here, I'm looking at bond enthalpies, so really I'm looking at breaking and making bonds. So in this one, you're always going to look at break minus the make. Break minus the make. That's something you just have to remember, break minus make. Something you could look at is the B is before the M in the alphabet. The way I look at it is break always comes first because you have to input energy in order to break bonds. And I know that because anytime we look at these, like we have already looked at reaction coordinate diagrams, you've always got this upward spot. You always have an activation energy you must overcome first. It always goes up. And that's because we have to input energy in order to break it. So here I am breaking a double bond, which is worth 495. Minus I'm making bonds, that's these ones over here. I'm actually not making any bonds at all because they're just two oxygens. So that's 495 minus 0, which gives me a positive 495. And that's how I got the answer there. People who got it wrong was because they got a negative 495. They were saying the B. So there they were doing make minus break instead of break minus make. That is a common mistake. The next one we're looking at is number 11. Number 11 is the heats of formation. So there, I'm going to be looking at products minus the reactant. And that's going to give me the change in H. The change in H can also come from using this equation here. So the change in H that I got for here is this 495. That was based on the bond enthalpies, the different bonds you're making. What I'm looking at down here is the heats of formation. It's just a different way to get the heat of the reaction, to determine if it's endo or exo. So products minus reactants. So the way I like to do it is I like to look at my products. The products are Fe and Al2O3. Al2O3 and Fe. Fe or any lone element on its own is always a 0. So I'm going to take my products, my Fe, which is 0, plus my aluminum, negative 1680. I'm going to minus all of my reactants. Notice I added the products together, and I'm going to minus, and the reactants all added together. My reactants will be 0 plus, that's what I'm trying to find is this question mark in this whole problem. So I'm just going to call that X. And that's equal to the heat of the reaction, which they told me is negative 860. So at this point, I just got to do some semi-simple math. I'm going to add 1680 to both sides. Oh gosh, I get a number 820-ish. Positive 820. There we go. And that is going to be equal to, notice right here, this is equal to the negative, that's my negative sign, negative X. Negative X. So that means X is equal to negative 820. And that's why the problem I got negative 820. If you got this wrong, it's because you said C. You just told me the opposite. So again, products minus reactants is what we need to do for that. As for the free response questions, that was the other thing I want to go over. As for the free response questions, for A, everybody talked about things being more massive, which was great. That's all you really need in the answer. I think you should talk about density, is my opinion, but for the AP people, they say that's good enough, so that's good. And then down here, our answers were pretty good. I want to just identify some key words here. They always, in these IMF kind of questions, they say, in terms of types and strength of IMF. So in other words, you have to list the type and the strength of each of the IMF for each of these parts. So that's the first sentence I would go for. I would say propene has LDF, blended dispersion forces, and vinyl chloride has LDF, blended dispersion forces, and dipole-dipole. First thing I would go for. Then I would say dipole-dipole is stronger than just the LDF. Therefore, a stronger one would have a higher attraction. Higher attraction leads to higher boiling point. So we pretty much did that, but I'm just trying to show you these key terms. Like whenever they ask these questions, just list them flat out. These IMFs, this makes it stronger or weaker, and then apply whatever the whatever physical property they're dealing with. Boiling point is a common one. And that should get you to where you need to go. Okay, that is my topics of the day. My drawing of the day. Well, I'm going to do a drawing for you. I'm going to draw you an elephant. Hopefully you saw that my kids just love elephants like crazy. So here's my elephant. I am not a very good artiste, but I have been watching the Kennedy Center. Has this guy named Mo Willems, and he's an author. And he is, so here's my elephant. He has a character named Gerald, and Gerald has glasses. So that is how I'm going to draw an elephant. I'm really a terrible drawer, but this has really been exciting for me. I love, like I said, that thing is about the eyes. He's looking up. He's just like so innocent and cute. But his eyes in different spots, he's got a totally different feeling. So there you go. I hope you have a good day. We'll see you tomorrow.